The universe is not silent. It is not still. It is a chaotic shooting gallery, a kinetic billiard table, where the balls are the size of mountains and the pockets are civilizations. For most of human history, we looked up at the night sky and saw only peace. We saw the fixed stars, the wandering planets, and the moon, our faithful companion. We felt safe. We felt central. But that feeling of safety was an illusion born of bad eyesight. When we finally built telescopes powerful enough to peer into the dark void between the planets, we realized something terrifying. We are not alone in the solar system. We are swimming in a swarm. There are millions of rocks, some the size of cars, others the size of cities, hurtling through the dark at speeds that defy comprehension. Most of them will miss us, as most of them will drift harmlessly in the asteroid belt between Mars and Jupiter. But there is a specific class of object that keeps planetary defense officers awake at night. They are the near-Earth objects, the NEOs. And among them, there are three specific names that appear again and again in the classified briefings and the simulation models. Three rocks that have the mathematical potential to reset the clock on human history. NASA doesn't like to use the word scared. They prefer concerned or vigilant. But when you look at the orbital mechanics of these three specific monsters, fear is the only rational response. If you want to understand the true fragility of our existence and join us as we track the invisible threats hunting our planet, make sure you are subscribed. The universe is trying to kill us. It's best to know how. Let's begin with the rock that caused the greatest panic of the 21st century. Its name is Apophis. In Egyptian mythology, Apophis was the great serpent, the enemy of the sun god Ra, the embodiment of chaos and darkness. The astronomers who named asteroid 99,942 knew exactly what they were doing. Discovered on June 19, 2004, by Roy Tucker, David Tholen, and Fabrizio Bernardi at the Kitt Peak National Observatory in Arizona, Apophis immediately set off alarm bells. Initial orbital calculations were wrong, but they were wrong in the most terrifying way possible. For a few breathless weeks in December 2004, the data suggested a 2.7% chance that Apophis would strike Earth on April 13, 2029. Let that sink in. A nearly 3% chance of the apocalypse. In the world of celestial mechanics, where probabilities are usually 1 in billions, a 2.7% is effectively a coin toss. Apophis is a stony asteroid, roughly 340 meters wide. That's about the size of the Empire State Building. If it hits, it won't be an extinction-level event like the dinosaur killer, but it will be a civilization breaker. It would impact with the energy of 1,200 megatons of TNT. To put that in perspective, the largest nuclear weapon ever detonated, the Tsar bomber, was only 50 megatons. Apophis would be 24 times more powerful than the strongest weapon humanity has ever built. If it hit land, it would flatten a continent-sized area. If it hit the ocean, which is statistically more likely, it would generate tsunamis hundreds of meters high, scrubbing the coastlines of the world clean of cities. Now, subsequent observations have refined the orbit. NASA has officially ruled out the 2029 impact. But here is where the story gets darker. We aren't scared of Apophis because of what it will do in 2029. We are scared of what 2029 will do to Apophis. On Friday the 13th, April 2029, Apophis will pass so close to Earth that it will dip below our geostationary satellites. It will be visible to the naked eye as a streak of light moving across the sky over Europe and Africa. it will come within 31,000 kilometers of the surface. In astronomical terms, that is a bullet grazing your cheek. This close encounter introduces a variable called the keyhole. Gravity is not just a force that holds us down, it is a force that bends paths. As Apophis skims the Earth's gravity well, its trajectory will be warped. If it passes through a very specific, a narrow window of space, a gravitational keyhole, only about 600 meters wide, Earth's gravity will tweak its orbit just enough to set up a guaranteed collision exactly 7 years later, in 2036. While current data suggests the keyhole passage is unlikely, there is a chaotic element we cannot fully model: the Yarkovsky effect. Asteroids are not static rocks, they spin. As they spin, they absorb sunlight on one side and radiate it as heat on the other. This thermal radiation acts like a tiny, microscopic thruster. Over decades, this tiny push can drift an asteroid's orbit by hundreds of kilometers. It is a chaotic, unpredictable force. We are watching Apophis. We are measuring its spin, its heat, its composition. Because if the Yarkovsky effect pushes it just a few hundred meters to the left, in 2029, and the Great Serpent might come back to swallow the Sun in 2068. If Apophis is the chaotic brute, our second nightmare is a silent, creeping inevitability. Its name is Bennu. Bennu is currently the most dangerous rock in the solar system based on cumulative probability. It is a carbonaceous asteroid, a primitive pile of rubble held together by weak gravity, roughly 500 meters in diameter. It is a relic from the very dawn of the solar system, a time capsule that has remained unchanged for 4.5 billion years. But Bennu is not just a scientific curiosity, it is a threat. NASA takes Bennu so seriously that they didn't just look at it, they went there. The OSIRIS-REx mission spent years orbiting Bennu, mapping every boulder, every crater, and even touching the surface to grab a sample. Why? Because to stop an enemy, you must know its anatomy. What they found was terrifying. Bennu is not a solid rock. It is a rubble pile. It behaves more like a fluid than a solid. If we were to shoot a nuclear missile at it, as they do in the movies, the shock wave might not shatter it. Instead, the loose rocks might absorb the energy, shifting and reforming like a sponge absorbing a punch. Or worse, we could blast it into a shotgun spray of radioactive buckshot, turning one bullet into a million. The danger date for Bennu is September 24th, 2182. Now 2182 feels like a long time away. It feels like someone else's problem. But in the lifetime of a planet, 150 years is a heartbeat. The cumulative chance of impact is roughly 1 in 2,700. That sounds low, but for a planetary catastrophe, it is uncomfortably high. So the specific fear regarding Bennu lies in its density and its rotation. Because it is a rubble pile, its rotation is speeding up over time due to the Yorp effect, a variation of the thermal thrust we discussed earlier. As it spins faster, it may begin to fling rocks off its equator, becoming an active asteroid. But the real horror is the impact scenario. Because Bennu is rich in carbon and organic molecules, it is dark, very dark. It absorbs a tremendous amount of solar heat. This makes its orbital drift incredibly difficult to predict with precision. If Bennu hits Earth, it releases 1,200 megatons of energy. But unlike a solid metallic asteroid, Bennu would likely break apart high in the atmosphere. This sounds good, but it's actually worse. It creates an airburst. Imagine the sky turning into a furnace. The shock wave would flatten thousands of square miles before the fragments even touch the ground. The heat pulse would ignite everything within the line of sight. Forests, cities, oceans, all boiled instantly. The OSIRIS-REx mission gave us a sample of Bennu, which is currently sitting in a lab in Houston. We are studying it not just to learn where we came from, but to learn how to kill it. We are testing kinetic impactors, gravity tractors, and laser ablation techniques. We are practicing planetary defense on a microscopic scale because we know that in 2018 too, our descendants might have to do it for real. The third rock is the one that truly scares the physicists. Not because it's imminent, but because it defies the laws of physics as we understand them. Its designation is 1950 DA. Discovered in 1950, lost for half a century, and then rediscovered in the year 2000, this asteroid is a monster. It is 1.1 kilometers wide. If Apophis is a city killer and Bennu is a region killer, 1950 DA is a climate killer. An impact from an object this size would throw enough dust and ash into the stratosphere to block out the sun for years. It would trigger a global winter, collapsing agriculture and starving billions. But the size isn't the weird part. The weird part is that 1950 DA shouldn't exist. It spins incredibly fast. It completes a full rotation every 2 hours and 6 minutes. For an asteroid of its size and composition, this rotation speed generates centrifugal forces that are stronger than its own gravity. By all known laws of mechanics, 1950 DA should have flown apart eons ago. It should be a ring of dust, not a solid rock. The fact that it is holding together suggests that it is bound by something else. Forces we call van der Waals forces. These are the weak intermolecular forces that allow geckos to stick to glass. 1950 DA is a rock held together by static cling and quantum friction. This makes it a nightmare to deflect. If we try to nudge it, if we slam a kinetic impactor into it, like the DART mission did to Dimorphos, we risk breaking that delicate cohesive bond. We might not push it. We might simply unzip it. And then instead of 1.1 kilometer rock, we have a cloud of millions of rocks, all maintaining the same trajectory, turning the impact into a global shotgun blast that covers the entire hemisphere. The date to watch is March 16th, 2880. The probability of impact is currently assessed at 1 in 8,300. But the window of uncertainty is massive because of that impossible spin. We don't know how an object held together by van der Waals forces reacts to the solar wind over 800 years. We don't know if it will shed mass, changing its orbit. 1950 DA represents the ultimate unknown. It is a reminder that our models of physics are approximations of reality, not reality itself. It is a ghost from the 1950s that has returned to haunt the distant future. We have talked about Apophis, Bennu, and 1950 DA. These are the devils we know. We have their names. We have their addresses. We have their schedules. But the thing that truly terrifies NASA, the thing that causes the real existential dread, is not the rocks we are tracking. It is the rocks we can't see. We have catalogued roughly 95% of the planet-killer asteroids, in the ones larger than 1 kilometer. We are doing a good job there. But as we go down in size, our blindness increases. We have found perhaps 40% of the asteroids the size of Bennu or Apophis. That means for every Bennu we know about, there is another one out there lurking in the dark that we haven't seen yet. And there is a specific blind spot that we cannot fix from the ground, the sun. Telescopes cannot look toward the sun. The glare is too intense. It blinds our senses. This means that any asteroid approaching Earth from the direction of the Sun is invisible to us until it is too late. This isn't theoretical. It happened. On February 15th, 2013, over the city of Chelyabinsk in Russia, the sky exploded. A rock roughly 20 meters wide, tiny compared to Apophis, entered the atmosphere at 40,000 miles per hour. It exploded with the force of 30 Hiroshima bombs. It blew out windows in 6 cities. It injured 1,500 people. And nobody saw it coming. Not NASA, not the European Space Agency, not the Russian Roscosmos. Why? Because it came from the direction of the Sun. If the Chelyabinsk meteor had been the size of Apophis, there would be no Chelyabinsk today, and we would have had zero warning, no time to evacuate, no time to say goodbye. Just a flash of light and then silence. This is the daylight danger. There are entire families of asteroids, called the Asteroids and the Apophis, whose orbits keep them entirely inside Earth's orbit, constantly hidden in the Sun's glare. We know they are there. We just can't see them. NASA is currently building a space telescope called NEO-Surveyor to fix this. It will sit in space, looking specifically into the regions where ground telescopes are blind. But until it launches, we are playing Russian roulette with the Sun. When we look at Apophis, Bennu, and 1950 DA, we are looking at the barrels of 3 different guns. One is a chaotic spinner, one is a fluid rubble pile, and one is a physics-defying impossible object. They remind us that the Earth is not a fortress, it is a target. For 4.5 billion years, Earth has been punched, melted, and scarred. Life has been extinguished 5 separate times. The dinosaurs ruled for 160 million years, far longer than we have, and they were wiped out in a single afternoon because they didn't have a space program. We are the first species in the history of this planet with the ability to choose our own fate. We are the first eyes to look up and see the hammer falling. The fear NASA feels regarding these asteroids is not a paralyzed fear. It is a motivating fear. It is the fear that drives the DART mission, the OSIRIS-REx mission, and the NEO-Surveyor. It is the fear that pushes us to map the dark, to calculate the orbits, to build the shields. We live in a shooting gallery. That is a fact. But we are learning to catch the bullets. The question is not if another rock is coming. The question is when. And more importantly, will we be watching the right patch of sky when it arrives? As we drift through this cosmic minefield, remember that our survival is not guaranteed. It is an active project. If you want to stay informed about the threats facing our world and the science we use to fight them, make sure you've subscribed and turned on notifications. The universe is vast and dangerous, and we are exploring it one disaster at a time. Until next time, keep looking up, because the sky is falling slowly.